In this video, we're going to apply derivative of a function or quantity to solve some application problems, specifically related rates problems. So in applied fields, in real life for the matter, sometimes in an event, several quantities are related. So what happens is, if some quantities change at some rates, well, first of all, then other related quantity will change. So if we know the rate at which other quantities change, then it's an interesting question to ask. Say, what about the rest of the quantity? How fast are they changing? So basically, we have related quantities involved, and we're interested in finding out the rate of change of a certain quantity when the rate of change of other quantities are known. All right. We'll be dealing with different kind of problems. So there's no unique formula to apply. Rather, there are some general steps we follow to try to solve this kind of problem. So no matter what the situation, first thing we want to do is try to draw something. If possible, the good news is a lot of times some geometric shapes are involved. So you can draw a picture of the shape, or even if there's no geometry involved, you can maybe make a list of quantities involved, anyway, so first try to draw something so you can look at them instead of keeping everything in your head, trying to imagine, right? Actually see literally the situation in front of you, piece of paper. So second thing you do, look at the picture, look at the drawing, look at your list, try to identify the quantities involved, label them. If there's a volume involved, use V for that. If there's a radius involved, use R. All right? So know what you're dealing with. Step 3 is to identify known rates. Sometimes they tell you how fast a quantity changes. That's a known rate. It's given. Also, of course, you need to identify the unknown rate or rates. And that's the one you're supposed to figure out. All right. And the next, step 4, look at your picture and see how those quantities are related. You need to establish an equation so that you can eventually solve for the unknown rate. So step 4 is extremely important. Set up some mathematical equation relating the quantities involved. How you do it varies from problem to problem. Sometimes it's a simple matter of formula, area formula, volume formula. Sometimes it's just some common sense. And then we're going to become experienced only after doing a lot of practice problems. All right, step 5. Well, once you set up your equation, the rest of the problem is pretty simple. Rest of the work is pretty simple. So step 5, You just differentiate your equation with respect to time. Differentiate everything, applying appropriate differentiation formulas, differentiation rules, product rule, chain rule, whatever. All right, so it's a calculus, pretty simple calculus, pretty much. Differentiate. Once you differentiate quantity, you find the derivative, right? Derivative of a quantity is the rate of change of that quantity. Then finally, you solve for the unknown rate. All right, so this is the general steps. Of course, we're going to go through the steps with each every examples. I'll show you. All right, let's see the first situation. So we're given application problem, word problem. We'll read it through and try to understand. At the same time, try to draw something as we're reading along. We may have to read again and again, to really understand what's going on. All right, let's just quickly see what's going on. A letter is placed against a building. Base of a letter is slipping, basically. It slips at the rate of 3 feet per minute. So we kind of know rate, right? Some known rate. Find the rate of change of the height of the top of the letter above the ground at the moment when the base of the letter is 30 feet from the base of the building. All right, so then make sure you read again until you understand what's going on. Sometimes you need to read a lot of times to really understand what's happening. So what's going on here? There's a letter, right? So let's draw a picture. So there's a wall or building, and there's a ladder placed against the wall, and this is the ground. So the bottom, as the problem describes, is slipping this way. What does it mean mathematically? Well, when they say the bottom of the letter is slipping, it's really saying the distance here is changing, is increasing. So we're going to call this as a D. Well, that's basically the distance between bottom of the building and the bottom of the letter, right? So write it down. So there's this quantity involved. As a matter of fact, we also know this D prime equal to 3 because it says it slips at the rate of 3 feet per minute. It's sliding away from the building, so this distance is increasing. If distance or quantity is decreasing, we would have to use a negative sign for that rate. All right, so next, find the rate of change of the height of the top of a letter above the ground at the instant. So before we finish the sentence, they are saying this quantity is involved. They want us to find, you see, as the bottom of the letter is slipping away, the top of the letter is sliding down along the wall. So maybe we'll just call this as H. like the height of the top of the letter above the ground. So there's h involved. And the question is, find the rate of change of the height of the top. So this is the unknown rate. H prime equal to what? When h is 30. Oh, when the base of the letter, sorry, no. When D is 30. When the base of the letter is 30 feet from the base of the building, meaning D is 30. What else do we know? Oh, we know the letter is 50 feet. That's 50. Right? So 50 is fixed. The length of the letter will not change, so it's a constant. Then there's a quantity D that's changing too. D is not always 30. We only know that it's when D is 30, we're supposed to find the rate. We're supposed to find out how fast the H changes. All right. So the bottom you cannot label it as a 30, because it's changing. All right. Well, we draw a picture, we label and identify everything. Next, let's see the steps, right? We draw a picture, we identify quantities involved. We also identify the rates, known rate, unknown rate. Now, write an equation that relates all those quantities. So look at the picture. We see in this case a right triangle with all sides involved, and all those sides actually clearly are of interest in this problem. The height of the letter, the distance on the bottom, the length of the letter, they happen to all form, they are the three sides that form this right triangle. So we can use Pythagorean theory. That is h squared plus d squared equal to 50 squared. So this is the identity that involve the quantities in this problem. That h, the d, are quantities that are changing with time. They're both functions of t. All right. So in any of those related rate problems, the variable is always t. Other quantities are functions of t. All right. So we have this equation. Next, differentiate. So remember, h and d are functions of t. So h squared is a composite. So we're going to have a 2h h prime general plus 2d d prime equal to 0. 50 squared is constant. Now again, what are we supposed to find out? We're supposed to find out h prime. So solve this for h prime. We can have negative 2d d prime divided by 2h. Basically move the d term to the right side and divide by 2h. So h prime is d prime over h. All right, so we solve for h prime. Now let's calculate. We know d prime is 3. We know d is 30 because that's the moment when we are supposed to find the rate of change of h. So d is known, d is 30, d prime is 3, but we don't know h. A lot of time we need to go back to the problem to find out the needed information. So basically we need to find out what h is when d is 30. When d is 30. And simple enough, just let's say d is 30. Now the hypotenuse is always 50. So here again, we're going to use the Pythagorean theory. The equation actually we already established here. So plug in 30 for d, then we can find out at this moment value of h. Okay, so h squared plus 30 squared equal to 50 squared. And then we solve it. It's pretty simple. H will be 40. (30 squared), move to the other side, simplify, take square root, it's 40. So we find out when d is 30, h is 40. Of course, d prime is how fast the bottom of the letter slips, is 3. So this it's going to give us 9 over 4. 3 3 is 9. 0 0 cancel out. 9 over 4. It's negative. It makes sense. It's negative, so it's decreasing. This quantity, h is decreasing. All right. Next, let's see a different situation. Says a stone is dropped in a pond. As a result, it's creating a circular ripple whose radius increases at some rate. After 12 seconds, how rapidly is the area enclosed by the circle or ripple increasing? So what's happening? Well, basically, there's a ripple that's enlarging. Okay, what we know is the radius. So there's radius involved. So called r, and we actually know r prime is 4. So 4 feet per second. That's how fast it's increasing. What else? Area. As a matter of fact, we're supposed to find how fast the area increases. So a prime is unknown rate. R prime is the known rate. How fast the radius increases, known. How fast the area increases, unknown. All right, it's a circular ripple. Actually, specifically, they're saying after 12 seconds, it means since we know how fast the radius increases, they're really saying how fast is the area increasing when the r is 4 times 12 seconds, because every second there's an increase of 4, so 12 seconds later the radius will be 48. So we're going to turn this information into a value of r. at the moment we are supposed to figure out A prime. Okay, so mathematical question is, what is A prime when R is 48, basically, 12 seconds later. All right, so we draw a picture, we identify quantities, rates. Next, set up equation. Well, it's a circle involved, area involved, so very naturally we can have A equal to pi r squared. That's area of a circle formula. Got our equation and differentiate. Now remember, of course, you can imagine both the radius and the area are functions of time. So differentiate it with respect to time to get the rate. So A prime equal to 2 pi r prime. R is a function, so r squared is a composite function. Pi is a number. So just bring the 2 down, differentiate r. Bring 2 down, reduce part by 1, then differentiate r, the inner simple composite function to differentiate. Are we ready to calculate for r prime? Well, we know r prime, so just plug in. So it's going to be 2 pi, r is 4 dA, r prime is 4, with a calculator. We see what this is. That's how fast the area is increasing. All right, pretty simple problem. It's still, you know, we went through all the steps discussed earlier. Draw a picture, identify quantities, identify rates, set up an equation, differentiate, solve for the unknown rate A prime in this problem. Okay, let's see a different problem. So, well, this time, a person who is 6 feet tall is walking away from a lamp post at the rate of 40 feet per minute. When the person is 10 feet from the post, his shadow is 20 feet long. Shadow is 20 feet long. Find the rate at which the length of the shadow is increasing when he is 30 feet from the lamp post. So what's going on? Well, first of all, let's say he's walking away. So first of all, there's a lamp post. So this is a lamp post. A person is walking away from it. Say it's pointing that direction, walking away from a lamppost. All right, and with that we try to label already things we know. The person is 6 feet. The height of the person is 6 feet. Do we know 6 feet walking away from a lamppost at the rate of 40 feet per second? What does it mean? Well, it means this distance is changing. So let's, for now, call this as x. So we know walking away from lamppost at the rate of 40 feet per minute. So x prime is increasing at 40 feet per minute. That's how fast he's walking. Right? So let's see. When the person is 6 feet from the lamppost, his shadow is 20. shadow is involved. This is his shadow. Let's call this as a y. So now the question says, the problem says when the person is 10 from the lamppost, his shadow is 20. Find the rate at which the length of the shadow is increasing when it is 30 from the lamp. So find the rate at which the length of the shadow, and that's y prime. So find y prime, because the y is the length of the shadow, right? Find the y prime when he's 30 feet from the lamp, when x is 30. So when x is 30. All right, so this is the mathematical question. Now we know other information too. We know, for example, when x is 10, his shadow is 20. All right, we'll see how to make use of that kind of information. Okay, so let's see how we're going to relate those quantities in our equation. Well, let's actually draw this line, because that's going to give us clearly the situation, the shadow, how we come up with the shadow, right? So apparently there right triangle, or actually right triangles are involved. When right triangles involved, usually we need to think about possibility of applying Pythagorean theory, area of triangle formula. Well, it's none of those cases, because to apply Pythagorean theory, all sides must be involved. As you can see in the picture, we know nothing about this side. We don't even know this side, all right, so for that matter. So Pythagorean theory is out of question. And this doesn't do with the area. So area of triangle formula is not relevant. Now what do we do? Well, this is kind of interesting. We see actually two triangles. Here's a little one, the shadow one side, the high one side, hypotenuse, and there is this ground, the distance here from the bottom of the lamppost and the tip of the shadow, and the high. So there are two right triangles. They are actually similar triangles. Usually, when we cannot apply Pythagorean theory, especially with the two triangles involved, two similar triangles involved, we need to try to take advantage of, or try at least, properties of similar triangles, because properties of similar triangles involve a lot of sides, and there are a lot of sides involved. All right, so for example, the y would be base of the smaller triangle, while x plus y is the base of the larger triangle, and there is a height of the person. Well, we don't know in this case the height of the lamppost, That's for now called H. Just so we can set up something, right? We know nothing about that yet. All right, so let's see what these properties of similar triangles tell us. Well, the sides are proportional. Corresponding sides are proportional. For example, we can say the height versus the height, right? So the height of the person, 6 over h. Height versus height compared to base versus base. So the base of the smaller triangle by, because on the left side 6 is the height of the smaller triangle, okay, versus the base of the large triangle. Well, that's an equation. That's an equation involving in particular, the y, the x, because we know x prime, we're supposed to find the y prime, known rate, unknown rate. So it's really important to make sure x and y are involved. Okay, and then we can differentiate and so on. In this case, h can be actually determined. Let's see how we do that. With this equation, we're going to use information that says that the person is 10 when his shadow is 20. So with this equation, we're going to see 6 over h equal to y. What's what? Y is 20. Y is 20 when x is 10. So it's 20 over 30, or 2 over 3. And we'll be able to solve this for h. So h is going to be 9. See, yes, h is 9. So this tells us h is 9. So that's the height of the lamppost. Plug in here, 6 over 9. Now we're not going to directly differentiate because we would have to use quotient rule. So let's simplify further. So do cross multiplication. So 6x, 6y equal to 9y. All right. Do cross multiplication, and this is going to give us 6x equal to 3y. We differentiate now, or we can divide by 3, then differentiate. Or either way, okay, doesn't matter. So let's differentiate this. So 6x prime equal to 3y prime. And we can cross out 3, so there's 2. And then plug in x prime 40 to get the y prime equal to 80. So that's the answer. So y is increasing at the rate of 80 feet per minute. And you can think about the situation when the guy is walking away from the lamp post, his shadow is getting longer and longer. All right. But anyway, so this is again how we follow the steps to try to find a certain unknown rate. And it's the same steps we follow. um, the part that we may do things differently is to try to set up the equation. So takes experience to be good at knowing what formula you have to use, what kind of equation you need to establish. Right, let's stop here.